Good morning and good day, everyone. My name is Tony. I'm a course advisor at EIT, and I will be your host for today's webinar. On your screen at the moment, these are the notification and sound settings. So you are able to turn on and off your notification and sound as you please during this session. And please post any question under the Q&A function at the top right-hand corner. You will see it there. So if the question has to do with our offering, general offering, I'll be able to assist that. But if it has to do with today's topic, it's more technical. Our presenter for the day will be able to assist regarding that. These are some of the common frequently asked questions. So everyone registered for this webinar will receive a copy of the PDF slide and a link to the video recording within the next 2 business days via an email. So please do make sure that you check your junk folder, spam folder, if it does not appear in your inbox. And yes, we provide a free digital certificate of attendance for live attendees for technical topic webinar. So there will be a link and actually a QR code and a short survey at the end of the webinar. So do stay with us to qualify for the certificate of attendance. Just a bit about EIT. EIT in all specializing in engineering. We deliver professional certificate, which are our 3-month courses, to our highest qualification, which is doctorate of engineering. So our programs are designed by industry expert, ensuring you graduate with cutting edge skill that are valued by employers. And another thing is that our program content remains current with rapidly changing technology industry development. Our vocational program and higher educational degree are registered and accredited by Australian government. We have programs that are also recognized under the 3 international engineering accords. Our lectures are highly experienced engineers and subject specialists with applied knowledge. The technology employed by EIT, both online and on campus, enable us to source our lecture from a larger global pool of expertise. And we also offer a unique delivery mode. We deliver our programs via a unique delivery methodology that makes users that will be assisting you throughout the program. Just moving right along. So this is our sister companies. They are different institutions located at different location. So the first one is ECT. ECT delivers interactive and online UK qualification. ECT is committed to providing students with a world-class education where they acquire the knowledge and skill that are applicable and valued in the industry. And the second one is ECST, Engineering College of Science and Technology. So ECT delivers a South African accredited qualification on campus. ECT is committed to providing students with a world-class education where they acquire the knowledge and skills that are applicable and valued in the industry also. So as you can see, we are offering bachelors of engineering, technology in electrical engineering, that's ECST. And you will see ECT on the other side. There are courses that are offered there also and on the screen. And you are welcome to check the website of each institution then if you then are interested. Just a disclaimer, the courses and qualification mentioned in this presentation are offered by separate legal entities operating in different jurisdictions, one in Australia, one in South Africa, and one in United Kingdom. Each entity is subject to its own local regulatory requirements and accreditation standards. So prospective students should refer to the relevant institution official website for accurate, up-to-date information specific to their location, including course availability, fees, regulatory status, and enrollment conditions. So you can respectively visit each institution's website and for more information. Moving right along, events conduct. Please keep discussion lawful and respectful. Follow the moderator's direction. Do not share illegal or abusive content. Recording is not permitted unless authorized. Breach may lead to removal. Just a moment. Moving right along. Today's topic will be mysteries, the case of the transformer that hammered at midnight. And today's presenter will be Professor Kalam. Professor Kalam, you can take over now.
Thank you very much, Tony. Thank you very much for the start of the session. You've been a great moderator till now, and I've been enjoying listening to you. I'll take control.
Okay, perfect. Thank you.
Can you see my slide, please? I'm in slide number 9.
Yes.
Okay. And you can hear me all right. Is it okay?
Perfectly.
Right. Thank you. Thank you very much. Let me put my speaker properly, and everything should be all right. Before I start the presentation, let me tell you why I'm doing this. Why am I doing this? And let me tell you that although I have huge amount of experience in teaching, and so that is not an issue. But you find that in this age, I have changed myself completely. And this topic, and the topics in this whole year that I'm going to do on the second Thursday and third Thursday for the next 8 months, you will find a different presenter than what you may have seen if you have seen me before, than what I have portrayed myself. Today, I am no longer Akhtar Kalam. Today, you might say, this is Peter Sellers. Peter Sellers, and anyone has seen Pink Panther will understand what I'm talking about. Peter Sellers was nothing but Inspector Jack Clouseau. Or someone might say, I am Inspector Colombo. That is Peter Falk, who was acting in that as Inspector or Lieutenant Colombo. Or you might call by me Sherlock Holmes. So you find that I'm going to talk about mystery. Mystery that experienced engineers do not know how to handle, especially when uncertainty occurs. In engineering, what is written in the textbook and what actually occurs could be quite geographically apart. So I want you to understand, I'm not going to do a fault finding tutorial. I want you to think like a professional, and you have to find out why that unusual situation has occurred. And this whole topic that I've started, I used to give a lot of short courses to the industry, and I used to have a session called Unusual Situation. That's how I developed the whole topic. As far as myself is concerned, I'm a retired person from Victoria University, and I'm still very active at EIT. I have a Other positions, like I'm currently an academic director and chair of the academic board at Texila. Then I have my own consulting company. I'm editor-in-chief of Australian Journal of Electrical and Electronic Engineering. And I've got a lot of adjunct positions and distinguished positions in many parts of the world. I have supervised a lot of more than 50 students who are doing their PhD and DEng and masters, etc. And currently, I have about 10 4 PhDs and 6 DEng students working with me. Um, I'm a consultant to the Electricity Supply Association of Australia, as well as to the industry in Australia. And I do a lot of these type of work in overseas, in particular when there's change management required. My education is PhD is from Bath, then my master's from United States in Oklahoma, and the 2 undergraduate degrees are from India. I'm a member of many professional organizations. And with that start, I want to talk about my program today. Today, what I want to do is, is, is to tell you what my objectives are. I'm going to introduce the case. We'll go to talk about critical questions that you should be thinking about. And what is so great about nighttime? Does Dracula comes out? What is so great? Dracula. Is it something dangerous which comes out in engineering? And why did the protection did not operate? Utilities spend hundreds of millions of dollars trying to get protection right. Why did not operate? And then what are the key technical lessons and what are the key takeaways? And then that will be followed by question and answer. So the first thing that I can think is, what is my objective? And I want to emphasize, I want you to think. I don't want you to worry about calculations, symbols, formulas, equations, nothing of that sort. Just think. Just think and enjoy the session. Enjoy the session. Think, I am not giving you a technical presentation. Think that I am telling you a story, a nightmare, a dangerous one, an unexpected one, unusual one, all the un that I can think of. And in fact, I have to emphasize, engineering is a very peculiar profession because here engineers are expected to handle ambiguity. And you'd be surprised, we have many serious incidents which started as something strange. And because it was strange, you have ignored it. So my objective today is to recognize the non-obvious fault systems. My objective today is to apply systems thinking to power equipment rather than just do it individual equipment. Think it as a system. I want you to understand the relationship or interactions or synergies between harmonics, magnetics, and mechanics. I want you to develop a professional diagnostic reason. I want you to get that idea that you will be a professional person. You will have some sort of diagnostic reasoning in you. And that's what I want to inculcate today. Now, the question says that I have in mind, it's very, very, very peculiar question I have in my mind. And in my mind, I'm thinking, why does mysteries matter? In our profession, you and me, all of us are engineers. Why does mysteries matter? The reason it is that many serious incidents were basically minor anomalies, and we could not solve it when they were minor, and they became a major incident. And once it becomes a major incident, is a lot of bucks, my dear, lot of money to be spent to overcome that. I must tell you, and many people do not believe me in this, but systems do not fail. Real systems do not fail, my friends. Okay? Don't you believe? You as a human being can fail, but systems do not fail. Normally, you'd be sitting in an office in the CBD, enjoying an air-conditioned office, and your substation or whatever is there is far off from where you are. Okay? But when there is data which is incomplete, you will be called upon. So in fact, you do get experience because of this intuition that you have, the structured intuition that you're going to get. Unfortunately, we have got huge amount of books, including mine. I have written so many books, but I can tell you they are only idealized condition. No non-ideal condition are there. An industry does not have and does not have to face in condition which is ideal condition, because your harsh environment is such that makes the condition very difficult to understand. Then what makes it a mystery? What makes a mystery? You know, I think it's a mental mode. If the system is wrong, me as an engineer should be able to detect that this is wrong. Not when experiment is necessarily faulty. That is too late. I should get the intuition right in the beginning. And therefore, if there is intermittent behavior, if there is time dependent symptoms, if there is non electrical root causes, if there is human assumptions which is making the reality. So your mental capability should be there, that you understand something is definitely wrong. I have to pry in this and find out. That is why your forensic or your sense of detective intuition will come in. So then, what defines the mystery? There are symptoms, but there are no alarms. And I was only talking last week. Circuit breakers were there. Circuit breakers did not trip, and the fault was there. So there was no alarm. Oh, it could be intermittent or time dependent behavior. Oh, the data could be conflicting. Oh, there could be multiple plausible explanations. Remember, these mysteries tells you where are the weaknesses. Because in engineering, you do a lot of assumptions. And where are the weaknesses? It is you who had made that assumption, so it is your problem. So you can't say it's a real-time problem. Then let me introduce the case that I want to talk about today. Let me talk about the case that I want to talk about today. There is a large filled power transmission, oil filled one, power transformer. It's in continuous service. It's in continuous service. No protection trips. But then people are complaining. that there is a loud humming noise at the night. Oh, this is scary. At midnight, just like the owls are there, the transformers are also humming. Oh my God, something is going wrong. Those who are not engineers, those who are not experienced with it, they will scare. They will be scared. They will think that ghosts are moving in the night. Are there witches around? What is making that humming noise? That's a beautiful example. This oil-filled transformer that I have has been in service for a long period of time. Protection has not tripped, but still that humming is there. So many lay people will be very, very surprised that why this is happening. This noise which is there is not from SCADA, and the fear which is there is not identified by SCADA. SCADA is supervisory, control, and data acquisition. It's not from there, but the fear is from the people. I'm telling you, you are telling him is telling her. Each of one of us are passing our fear to our neighbors. And this initiates stress in you. And very hard to express this technically because nothing has gone wrong. Protection has not tripped. It is in continuous service. The company has paid $50,000 to buy that oil-filled transformer. Still, in the midnight, exactly at the midnight, the ghost and the witches, everyone else is coming out. A strange condition. So, you want to do some initial symptoms. That is where my friend Inspector Jacques Clouseau comes in, Sherlock Holmes comes in, and Lieutenant Colombo comes in, not Akhtar Kalam, not any one of you. Okay. First symptoms is that it always happens at midnight. Very interesting. And it persists for several hours, not for a few minutes or seconds or it's gone. No, it persists for several hours. Up to early morning, till dusk time, you will hear that noise. And this thing, I think, happens when the sun shines, it all goes away. My God, why is this happening? So somehow or the other, when you are doing the diagnostics, you will say that there is a time correlationship between daytime and nighttime. And that to deep night, I'm talking about midnight, not early part of the night. And to early morning, dawn time, I said, that noise happens. As soon as you see this, it should raise flags. It might be possible that if there is an electrical fault, okay, it might be possible that there is an electrical fault of some sort. But in actual practice, electrical faults rarely follow the clock. So that never happens. I can tell you that. So my friends, let me go to the transformer. Let me take you to your second year in engineering. And in second year of engineering, my friends, if you remember, in second year of engineering, you did a lot of things. And one of them was magnetostriction. And this always happened at about 100 hertz or 50 hertz system. Okay. And this was always happening, such type of systems, this magnetostriction. What is this magnetostriction? This is a property of ferromagnetic materials. And the cores which are there there is iron, nickel, and cobalt. And that is what, you know, this property of this material changes the shape or dimensions when there is an external magnetic field. See, there are external magnetic fields which are here. There are external magnetic fields. Okay? And this is purely because of reorientation of the internal magnetic domains. This reversible phenomena allows materials to convert magnetic energy into mechanical energy. And therefore, there is a strain. Strain, that means there is an expansion or contraction. And this expansion and contraction is the cause of that humming noise. And you find this problem in sensors, in actuators, in transducers. And very simple, right? If it is expansion, it is positive magnetostriction. If it is contraction, it is negative magnetostriction. And there is an effect called Villari effect, and Villari effect talks about mechanical strength changes the magnetic properties of a material. Application could be in ultrasonic transducers, torque sensors, actuators, many type of devices. The common examples, however, is that it typically happens at 100 or 120 hertz hum, depending on what the frequency of your supply is, 50 hertz or 60 hertz. And the hum occurs in the electrical transformer. And this is caused by the iron core expanding and contracting. And it does that twice per cycle. That means 50 hertz becomes 100 hertz and 60 becomes 120. And that's where the expansion and contraction is going on. So it's going 2 times in a cycle. This was discovered not now, my friend. In 1842, it was discovered by Prescott. And he saw the changes in the iron sample. So I don't want to go much more deeper than that, but you can find that out, that this is a real thing which happens in transformers. And in particular, when it's load independent, the humming sound is more. And this is not constant. It is not time specific. Although I did tell you, it starts at midnight and goes up to early morning. So my friend, you as an engineer, now you are no more Inspector Clouseau, you are no more Lieutenant Colombo, you are no more Sherlock Holmes. You use your engineering brains up till now, what you have read, okay? And think about it. The first thing that comes in your mind is the transformer is aging. First thing that comes in your mind, transformer is aging. That means if the transformer is aging, my friend, then you should look at how much is the age of that transformer. Normally, transformer's life is 40 to 45 years. And your transformer is starting humming right in the early part of its life. So that theory is not right. Because if you change that transformer, you're going to go to your bosses and tell them change the transformer. He will say, go jump in the lake. We just bought this transformer 5 years back. So definitely it's not the aging part. Although it's very comfortable to say, it's aging, therefore change the transformer. That's the easiest way. It's a very comfortable explanation. And in fact, you'd be surprised, many engineers often jump to this conclusion and use this explanation because it's comfortable, low risk. Once you change it, that's gone for that period of time. Again, after 5 years, another problem will come, and I'll tell you right now. Or the core which is there in the transformer, they are loose. Or there's a problem in manufacturing. The guy who made the transformer, they goofed up. And some of you will take another casual look and say, these things are harmless, so no problem. So you've got 4 reasons, and all 4 reasons are great example of what an engineer will do today. That's immediately that's what the engineer will do today. One is very expensive. The other it means to change the core. The third blames the whole industry because of that. And the other one says, it's not my problem. It's harmless. No problem. So you've got out. There's a bigger issue now. Now, I want to just go and say, what is a normal transformer noise? Noise definitely comes from magnetostriction. It is load independent and is constant over time, and it's only twice in frequency. That means on a 50 hertz system, it's at 100 hertz, you get this. And I've told you what a magnetostriction is. So now I have done my analysis, and I have come to the conclusion. I went to my boss and he kicked me out of the office. And he says that I'm not going to spend a single farthing. I've just spent $50,000 in replacing this transformer 2 years, 3 years, 5 years back. So I'm not happy to do that. So why was the symptoms that you had did not fit the theory? Your evidence that was there is contradicting the theory, the trust evidence. The trust evidence is not there. Noise was time dependent, no increase in load, no temperature rise, no oil or gas anomalies. Why did it fail? Why did it hum? Why is it making that peculiar noise? Why is it scaring the hell out of me? So when that happens, my friend, what you will do, some, like a typical standing engineers would do. They would start doing all the tests, just like the doctors. They don't know what is happening. They will ask you to do ECG, they will ask you to do sugar test, they will ask you to do blood test, they will ask you to do heart test, you name it, and they will test everything. That is exactly the same way engineers would do the same thing. They will do a DGA, which is dissolved gas analysis. They will try and find out what is the quality of oil, is it acceptable or not? Look at the winding temperature, you find it stable, load current has changed. So what the hell has gone wrong? And this is where you as an engineer, your whole mindset stalls. And in fact, if you're a junior engineer, you get stuck. Because the standard diagnostic says, okay, all your blood test, your sugar test, your whatever test you have done, everything says you're okay. So what is wrong? Why is your equipment humming? So my mystery deepens. And I start asking questions. And the question that is there is a very basic one. If nothing is broken, what has changed? Nothing is broken. I can't go and change the transformer. I can't request anything new to happen. I can't do any tests. Why is it humming? Why it is humming? So let us see why it is doing that. why it is doing that. So I try and broaden my scope a bit more, expand it a bit more. I now I now look at the electrical behavior. I look at the mechanical response. I try to find the magnetic forces, look at the configuration of the network, and look at the environment. This has nothing to do with electrical engineering, mechanical, magnetic, configuration of the bed, environment. So instead of thinking like a design engineer, now you have to think like a systems engineer. And in system, there is no boundary. You can't say, I'm an electrical engineer, this is a mechanical problem. You can't ask any engineer. You have to be holistic. You have to be able to solve the problem. It's not necessarily what your specialization is. So, my friends, I want you to think about it. My friend, just think about it. I want you to think. Don't think component, think system. Don't think as a single transformer. Think as a system. So let me now try and poke a bit more. I do what my friend Inspector Clouseau would have done, my friend Lieutenant Colombo would have done, my friend Sherlock Holmes would have done. I look at the switching operation under off-peak condition. I look at the capacitors bank when they are switched in. I look at the reconfiguration of my feeder. I look at the voltage regulation changes which has taken place. And you'll be surprised. You can note network reconfiguration normally happens at night. If you ask any engineer, they will say do all the network reconfiguration at night, and that is because of efficiency and maintenance. You do not want to block your customer. You do not want to momentarily dip your supply so that customer is shortchanged of electricity. So you do all these network reconfiguration at the night time. And then the question comes, why night time? Why night time? Why do you want to do it night time? Very easy. You want to do it off peak. You want to earn more money on peak. You want to do all these switching, etc. off peak. You might, in the night time, you might have the capacitor bank maybe energized. Your industrial and EV load changes at night time. Your harmonic profile is different in the night time than in the daytime. The system becomes less complex in the night time. So I would have asked you a question at this juncture. What changes? Darkness, it becomes dark. That definitely happens. What else changes? And these are the things that I've talked to you about. Off-peak conditions are there, charges are there, capacitor banks are there, okay, load changes, harmonic profile shifts. So since I talked about harmonics, I wanted to just mention this word harmonic and explain a bit on harmonics, just to brush you into what you may have done some time back. And the beauty is that many protection equipment which is there, when harmonics occurred, they are blind. They can't see that. So let us introduce what is this harmonic. Because harmonics can dramatically change magnetic forces without increasing the RMS current. This is due to the presence of that great third harmonic voltage whose frequency is 3 times that of fundamental frequency. So the frequency is 150 hertz when the frequency is 50 hertz. The transformer core is made up of laminations. You've seen those laminations with insulation in between the lamination. and the lamination are stacked together and they are joined with a bolt. When a transformer is energized, say from a 50 hertz line, the laminations move to and fro, or it vibrates 50 times in 1 second. If a third harmonic voltage is present, the transformer lamination will no longer be 50 times, it becomes 6 times more. It will be 300 times a second. In this rapid vibration per second causes the humming sound you have heard. It can be reduced if the laminations are strongly bolted together. So, definitely, it's generated by harmonics are generated by nonlinear loads. Magnetic distortion increases. You can't see it every time. And it can excite the mechanical structure unless and until you have done a tight bolt, you tightened it up completely, or else this third harmonics will occur. Now, my friends, if you look at the relationship between harmonics and transformer cores, uh, there is distortion on the waveform. You can see the distortion. Here's the distortion. Look at the second graph. I told you magnetostriction increases, vibration is amplified, and you hear an audible noise. This distortion is the one which is producing the mechanical sound, humming sound, something like that. This links electrical behavior to mechanical sound, and this is a classical interdisciplinary effect between the electrical generation and mechanical impact. So, my friend, this time, let me explain to you what is resonance. And XL is equal to XR. Everyone knows that. Capacitor bank, you add capacitance. Transformer, add inductance. There's certain frequencies amplified. Harmonics can be magnified. Remember, resonance is not a failure. Many engineers do not know that. They say resonance is a failure. Resonance is not a failure. It's just a physics. So my friends, let me go a bit forward and let me identify my midnight trigger. My first trigger is that the capacitor bank switches in at midnight. That is my first trigger. The capacitor bank has switched at that time. Harmonic resonance started. The core started vibrating, and you hear the audible sound. And that's been intensified. And my friend, the transformer responded normally. For you, it was an abnormal condition, but a transformer did exactly what was predicted. It knew capacitor bank comes up, harmonic resonance occurred, core started vibrating, and the humming noise occurred. So, my friend, the question then, some smart aleck might ask, Professor Kalam, why the protection did not operate? What happened to the protection? There was no overcurrent. There was no thermal overload. There was no differential imbalance. There was no insulation stress. What the hell will protection do? Protection detects damage, not discomfort. Protect systems detect damage, not discomfort or nuisance effect. It doesn't do that. Protection is an intelligent device. I mentioned it many times in many of my lectures. Protection is purely an intelligent device. The operation is done by circuit breakers. So if there is no overcurrent, no thermal overload, no differential imbalance, what the hell will protection do? It will not operate. The protection was perfectly fine. Now, my next thing that I have, why did you hear the noise? And why did all your neighbors hear the noise? Why did your friends hear the noise? because ambient noise in the night time is reduced. So any other noise is amplified because the normal hum and bum of the whole place reduces dramatically in the night time, and therefore this noise increases. Your human hearing becomes very sensitive at that time. And in the residential proximity, there is hardly any noise. And psychologically, there's an amplification over here. You'll be surprised. Many of your engineering problems are through human perception. Engineering problems often become visible through human experience. So, my friends, let me try and start patching up and try see how do I verify this? Okay, what do? Do harmonics measurements. Look at the switching sequences. Look at the temporary capacity isolation. Look at monitoring the acoustic. Remember, if you have got hypotheses, hypotheses must be detected, not defended. Good engineers like you are will always confirm hypotheses, not just tell good stories. So I'm trying to confirm my root cause. Noise has coincided with the capacitor switching. Harmonics level was increased. Noise ceased when the configuration changed. Root cause confirmed. Evidence closed. The case is done. It's not an opinion. It's absolutely fact. So my friends, I've done that. And I now can look at my implementing the engineering solution. I can adjust the switching time. I can add harmonic filtering. I can install monitoring. I do not have to replace a transformer. Remember, $50,000 I've saved the company. So good engineering often saves money. Highlight cost avoidance. You can see I'm trying to avoid the cost, and I'm trying to make my asset life much more greater. So now, let me tell you what's the cost. I mean, we now do everywhere we are doing risk management and cost benefit analysis. I did not replace my asset, so it was unnecessary. There was no outage, no service disruption, and I understood my system properly. This is asset management excellence. I've utilized everything that I can think of. And what are the lessons that I have learned, my friend? What are the lessons I have learned? And the lessons I have learned is very simple. Just looking at the symptoms, hearing that humming noise, you don't go and change the transformer. That poor equipment is innocent. It is not the equipment, it's the system which the interaction has dominated, and the time patterns matter. So remember that your technical learning to professional judgment is very important. And just going a bit further, and this is extending my friendship to you, I want to go a bit further and see what are the common engineering pitfalls. One of them is we have tunnel vision. Others is we depend too much on alarm. I'm not taking consideration of soft evidences, and I want to replace. That's the first thing. Anything goes wrong, you replace. Those days have gone when you try and analyze why this thing has happened. So, mistakes are often cognitive. That means perceptive or rational. They're never technical. So encourage humility. I'm trying to encourage humility, my friend. Even experienced engineers fall into this trap. So if you look carefully, what I have done, my friend, what I've done, my friend, I'm looking at demonstrating my professional skills. I have started thinking as a system. I'm looking at interdisciplinary knowledge, environment, mechanical, electrical, magnetic, you name it. I'm looking at evidence based reasoning, and I'm trying to communicate with the stakeholders. This is what will make you into a senior engineer. If you start thinking like a system, if you have knowledge, interdisciplinary knowledge, that means you can look at the synergy of what is happening and look at evidence base and you can communicate it. That will make you into a senior engineer. So, my friends, I would like to, towards the end of my presentations, I would have liked to ask you questions and I'd like you to think about it. I know we don't have that much time. If you were there in that position, if the protection data is normal but complaints persist, what would you do? You cannot justify just changing the transformer to the management. That will not work, my friend. What would you do? I want you to think about that. And in fact, in fact, I want you to reflect how, as a junior engineer, you would solve this. What experience was critical? How could procedures improve detection? This is how you will start gaining the gaining the professional growth. And if you look carefully at the broader industry parallel, ferroresonance incidents and false strips are always there. Harmonic induced relay matter operation has been there for donkey of years. Cable sheet heating, cable failures due to induced current has been there for donkey years. HVDC harmonics and vibration issues have been there. Relay misoperation from CT saturation has been there. Okay, so this case of transformer humming is not an isolated case. This is a mystery, but this is not a unique case. You were incapable of solving the problem. You were not capable of solving the problem because you did not look at the system value. You only looked at that equipment. And your immediate answer, replace the transformer. So I end with a closing thought. My closing thought is not all problems announce themselves electrically. They're not going to say, I am in fault, I am at fault, come and save me. Some of them speak through sound. Some of them speak through time. Some of them speak through behavior. Look, my friends, I have not done any formulas. I have not done any symbols. I've just told you I've used reasoning, and that reasoning tells me that sound, time, and behavior is more important than the problem was. So, my key takeaway is as follows. Not all faults are failures, my friend. Time patterns matter. Network behavior matters. Investigation will beat assumption. So, my friend, as I told you right in the beginning, and I'm concluding it, the transformer is humming at midnight because of magnetostriction. This is because the core is expanding and contracting. And this is amplified due to resonance, due to load harmonics, especially at night, because the ambient noise in the night time is low and reduced. And it is double, 100 or 120 hertz, depending on the system frequency. So investigations involves measuring acoustic level, analyzing the load, and inspecting for loose core component. So when you're looking at the cause, please look at the physical cause. That's the first thing I would look at. Then you find why the midnight factor. Midnight factor had nothing to do with engineering. Then look at resonance and looseness, and then do the investigation. After you've done the investigation, it was a very easy thing. You just tighten the core. That's all you had to do. So the common fix would be tightening the core bolts, reinforcing structures support, or replacing vibration damping materials. So, my friends, what I've done today, I'm trying to make you into a professional engineer. I'm trying to tell you textbook do not have all the answers. You think the textbook has got the answer. No. Real systems have stories, lot of stories. And I'm going to tell you many stories. I'm going to tell you 24 stories. I've only done 4 of them till today. But you as engineer must listen carefully. Curiosity is purely a technical skill, and it's good to be curious. So this is purely my mentoring slide to you, and my final thought to you is as follows. My final thought to you is as follows. My friend, the system was speaking. The question was whether you was listening. I was the system, whether you were listening to me or not. With that, I have completed my presentation for the day, and I would like Tony to take over. Tony, you're back to you, Tony. Tony, are you there? Yep.
I'm
I'm stopped
here.
sharing.
I'm here, Professor.
I'm
Or let me take control.
I've stopped. Yeah. I've stopped sharing now. You can do whatever you want to do.
Oh, okay. Let me just quickly
Yeah,
put
recap.
this.
You have to do the recap.
Let me just quickly put this
I
up.
I I I was trying to be on time. I see that I've gone just 2-3 minutes over time. Go towards the end.
Yeah, but it was
Go towards that.
good. Let me just resume. So thank you
Yeah,
very much.
that is the
For
slide.
yes, this is the slide that we were at.
Yeah.
Then yeah, thank you very much, Professor Kalam. I was glued to my screen the whole time listening. It was very informative. And yeah, one gets curious, I think, after listening to your presentation. Thank you very much. And would like to also thank our attendees for taking their time and attending this webinar today. Any questions that we have 2 minutes. We have 2 minutes to ask questions. I'm not sure if there are any questions that you saw. Let me see. Let me see if there are any questions. Electrical technologist. I think our attendees are okay because there aren't any questions asked. Let's just give it a minute or just some few seconds for questions. If there aren't any questions after that, we'll just close the session then. I'm going to be sharing. Okay.
I'm glad there were people from various parts of the world who enjoyed the presentation. And I'm
Yes.
so glad that it's not only engineers, there were technicians in there were technologists, and they found it very informative. I'm so happy that even a solar installer and electricians were there who who deal with these type of issues daily on a single and three-phase basis. And 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 I see that Johnson uh, understands this part of harmonics to be very, very curious experience. Uh, so I don't know about other uh, previous webinars. Tony might be able to tell about previous webinars and how they can get access to it. But thank you very much, Joshua, Ibrahim, and all of you. Uh, this humming, this is one interesting question. Tony, you missed that. Could this humming lead to overheating or power loss? What do you think? This is one engineer who is a T engineer What do you think? It's a very good question. Will it give you overheating or power loss? Anyone to answer that?
Yeah, we can answer on the chat. I think
Yeah, yeah.
so they won't be able
It's the
to.
same thing, yeah.
Yes, and just for our attendees on the screen, these are our upcoming courses at DIT. You can just see the programs on the left-hand side, and on the right-hand side, those are the start date for the upcoming programs. And yeah, still upcoming programs on your screen. So now the QR code, you can claim your attendance certificate of attendance. I'll also share a link now on the chat box. And on your screen now, these are the details, contact details for each institution, EIT, ECT, ECST, respectively. You can reach out to them, and the course advisors will be able to assist regarding anything that you may have. So let me just leave this on the screen, the QR code, and let me just share the link on the chat box. Professor, you wanted to add something?
Yes, I did. Just a quick one. The answer to that question, which was asked by Engineer T. The
Okay.
answer is that there will be no impact on heating because there is a cooling transformer is always there. Every transformer has got a cooling system. No impact. Overheating will not have any problem. There may be some small losses because you're getting damping and you're having vibration and the stacks and the cores are clapping each other. So there may be some small losses. That's about the only thing that might happen. Okay. So it was great to see all of you and I've enjoyed it and I hope it was of some value to you. Please come. My next session that I'm going to have, I think it is on the on the 12th of March and 19th March. And in those two sessions, I believe that these two sessions will be very interesting in the sense that they will be, the 12th March will be on paralleling generators. You've got two perfectly matching machines and they do not share each other. That was my 12th March. And the 19th March, I'm going to talk about the Earth fault that didn't return to Earth. So these are the two sessions that I'm going to have on the 12th and 19th March. Love to see all of you there and wish you all the best and take care and stay healthy. Tony, with that, I
Thank
finished.
you. Yeah, thank you very much, Professor Kalam. That it was touching. It touched me. I can say that. So thank you to all other attendees that attended, took their time to attend. And yes, I've shared the necessary link on the chat box. And on the screen, as I've said, is the QR code. You can scan to claim your certificate of attendance. And just check your emails, junk folder, in the next 2 business days for the recording of this session. I think we can call it a day. Professor Kalam, what do you think?
Bye
We
bye.
are
Bye
done.
bye. And thank you
Thank
very
you.
much, Tony. You have been a great moderator. I've enjoyed having you over here. Thank you very much.
Thank you very
You
much.
are one of the
And
best amongst all the great ones. You are the greatest. Have a nice day.
thank you, Professor Kalam. You too. Have a nice day. Have a nice day, everyone. Cheers. Bye bye.